Hello everyone, in this video I wanted to show you the undervolting for this system. It's a Ryzen 7600 and a b650m HDV M2 from Asrock, which is my usually go-to motherboard for Ryzen. So you can see it's been running 8 hours of VT3 by Cruncher, and I will run now PyPrime, as I forgot to run this in this preparation for the video. And so you can see in the background you have ADA 64, and these are the results. Almost 61,000 for memory read. As you can see here, our NOS bridge clock is 3,000, so memory is 6,000, and it's a pretty basic setup for Ryzen. I didn't try anything fancy, 6,200, because I've been running into a couple of issues with the systems cooking up during the summer last year. So I decided to just stick to 6,000 for my systems and just undervolt the hell out of it, and also paste a fan on them, because currently I'm testing without the GPU, and I will eventually put the GPU inside and put a lot of fans around this small case, because I like small cases, but of course the airflow has to be a little bit forced on every side, and I'm gonna put a fan down there, a small fan up down there, pumping air to the memory, and of course exhaust fans on the top and everything. So back to the actual results. So here's wich Cruncher 5B. That's MEM5 is passed. PC Mark has passed. I use PC Mark to test the undervolting, the curve offset undervolt, to give a realistic scenario for that. This is not pushed on the curve offset, because that takes a lot more time to properly test. So I'm just recording this to show the memory tuning and a little bit of overall stuff, because memory tuning is a little bit more universal. There's more consistency between different sticks. These are Kingston Fury Beast. Let me check what exactly these are supposed to run at. So yeah, this is CL30 3636 at 1.4 volt. As I understand, this could be either M die or A die, and based on the fact that this machine is not scaling very well with the lowering the TRFC under 800, that means that I should be on M die. As I lower the TRFC, my latency goes down, but like PyPrime score goes a little bit up. ADA 64 time latency goes down, but Limpac results get worse, so, and more inconsistent. So yeah, it might also be related to the fact that I'm running very low voltages. PyPrime usually scores around 205, but I've been moving a little bit of stuff around, so it might go a little bit higher than that. Let me see. So 207, 8. What is that going to do? 209. Yeah, moving stuff around really brought the score a little bit down, but yeah, it's usually around 200, 205. And so let me open the most important thing, the timings. So here it is. SOC is 1.105, and that is of course super tighten up. Going lower will make my Limpac scores jump around. Speaking of Limpac, here's the scores, and the fact that the scores go down in the end is because I'm thermal throttling. Of course, I'm using the Wraith cooler. I don't know which exactly is, but the one with the red ring. So it's not the one that came with the CPU, but I had this one around, which is a little bit taller and has the copper core. So it's a mid-range stock AMD cooler. Maybe it's the right styled. I don't know really, but yeah, it's thermal throttling in the end a little bit. So that's why the curve goes like that. And so it's 313 for the Limpac Extreme. Well, yeah. CLD of VDP is 0.8. That's bottomed out. VDD and VDDQ are almost bottomed out in a way that I can lower them and I can get a little tiny bit like the same scores, or maybe a little tiny bit better, but they're more inconsistent. So I don't want to have a Limpac scores running around, which is to me it means that you're not 100% stable. So I'd rather have 313 stable in the middle than having jumping between 314 and 309. 309, sorry. Sorry, I just decided to scale everything a little bit. So yeah, VDDIO is bottomed out, of course. This one gives lower scores before crashing, so it's quite easy to tell when you're bottoming out, you start to lose score. And this one doesn't move as far as I can tell. It's always 1.1 on every configuration. But yeah, I can see the VDDQ is super low, especially this one is like closer to JDEC spec for 4800 memory. Let's go to the BIOS and see what I did there. Now keep in mind, in my lab I use broken screens to work, so this screen has a kind of broken bottom half of the monitor of the LCD. But yeah, so DDR3 3000. So I had to raise the timings, of course, to get the lower voltages to work. So CL32 it is, but of course I'd rather have CL32 at 1.25 than CL30 at 1.4. To be perfectly honest, CL30 was running at 1.32 volts, but I decided to go 32. The performance impact is really nothing. And this one I had to rise by 1. TRC is bottomed out. TWR is not. I mean, I could go lower, but I will start to get trade-offs between latency. I get lower latency, but also lower impact scores. So I decided not to move it. This one is not bottomed out. I'd rather test it like that, and that's how I will leave it. So TRC is where it. This test were done at 700. That's interesting. So yeah, TRC works better around 700 to 800, and I think I could get. Yeah, as I said before, if I lower this, I can get higher scores on some tests, and then more inconsistency between different runs. So I left it like this, and that's also for more safe operation under hot environments. RTPS20, that was doing the same. So that's a common theme with all of this tuning. Is you get, if you lower the timings, you get better scores for like faster and latency bound test, but then you can get regressions in mostly in impact, and I want to play on the safe side, and I didn't touch those because those were everything was doing the same basically. So I was able to get the impact to 315, but in that same run I would also get 305, so that was definitely not stable in my opinion. And so 103 for the VDIO, as you can see. These are the memory voltages. I didn't touch this. I don't know if that makes any difference, because that's only an input voltage, so it shouldn't really affect what comes out in the end to the memory and the efficiency of operation. If anyone has any information about that, let me know. SOC, as you can see, it's actually reported like 0.01 higher than timings, but that is the one I need to get it stable. And this one doesn't work. VDD MISC doesn't work, and these are, I can go lower with this, but I'm playing on the safe side a little bit. But like defaults are 0.9, I think so. And then you can go to just to check the curve offset, which really is the thing that would need more. It's 20 actually. Yeah, it's working at 20, so that's fine. That's usually where I mean, I've had good luck with 30, and then I tried to like do per core undervolting, and see some cores were doing 30, some were doing around 23, around 20. So I feel very safe with 20, also because I didn't modify the 85 degrees limit, so the CPU shouldn't get too hot. That's how I feel safe going with that. Might feel like I could go down with the rabbit hole of per core offset, but I mean the client also wants the machine, so I have to stop at some point. And I guess that's all for the video. I hope you found it interesting and useful. If you want to experiment with these things, remember this is a dual DIMM setup, so it's probably like requiring less voltages for some rails to operate compared to a 4 DIMM setup. And that's really all for the video. Ciao!